prime factorization. Prime factorization. So prime factorization has two words here. One, prime. Prime comes from prime numbers. Numbers with only two factors, one and the number itself. That's a prime number. Next, factorization. Factorization comes from factors. What are factors? Numbers that can divide other numbers. So what is prime factorization? We know prime comes from prime numbers, numbers that has only two factors, one and the number itself. Then factorization coming from factors. What are factors? Factors are numbers that can divide other numbers. So what is prime factorization? What will you say? Prime factorization is the process of writing any number as a product of its prime factors. Prime factors. Now, remember, prime numbers had only two factors. The opposite of prime numbers is composite numbers, numbers with more than two factors. Now, we have a word here that we don't know, composite numbers. Composite numbers. What are these composite numbers? Are numbers with more than two factors. Numbers with two factors, we call them prime numbers. Remember, that is whatever we said last time. Then we have numbers with more than two factors. What name will we give them? Composite numbers. Now, write and say, these are numbers, composite numbers, these are numbers with more than two factors. So already you know, opposite of prime numbers is composite numbers. Opposite of even numbers is odd numbers. Opposite of factors is multiples. Already we are learning opposite. This is not English, it is maths. Now, prime factorization, we have prime numbers and factors combined. We have composite numbers. This is whatever we are going to deal with here. Now, composite numbers, we have said, these are numbers with more than two factors. Composite numbers are numbers with more than two factors. That is composite numbers. Numbers with more than two factors. So, prime factorization. Already right now, I know you can tell what prime factorization is. Prime factorization is the process of expressing, or is the expressing of composite numbers as a product, meaning that multiplied as a product of their prime factors. Meaning that already we know prime numbers and we know prime factors. So let us write prime factors here. We are not going to leave anything for chances. We must know everything. Composite numbers, these are numbers with more than two factors. Prime factors. Prime factors are factors that are prime numbers. Are factors that are prime numbers. Are factors that are prime numbers. Hey, that English. English teachers, please. Let us know the exact word, the word that we are supposed to be using here. Are factors that are prime numbers. Prime factors are factors that are prime numbers. or are prime numbers that are factors. Anyway, you can are prime numbers that are factors, or are factors that are prime numbers. Are factors that are prime numbers, or are prime numbers that are factors. Any way you can talk about prime factors. Composite numbers, these are numbers with more than 2 factors. Composite numbers, these are numbers with more than 2 factors. Prime factors are factors that are prime numbers, or are prime numbers that are prime factors. Is there anything now that you don't understand from the definition? No. So from here, after knowing composite numbers, so any composite number that you have, 36, that's a composite number. It has more than, even 9 is a composite number. Even 6 is a composite number. 40, 100, 1 million, 700. These are composite numbers. Numbers with more than 2 factors. They are called composite numbers. Prime factors are factors that are prime numbers. Are factors that are prime numbers, or are prime numbers that are factors. You can say whatever you want. Now, let us define prime factorization. What is prime factorization? So, prime factorization is expressing composite numbers. Prime factorization is expressing composite numbers. Prime factorization is expressing composite numbers as a product of their prime numbers. Prime factorization is expressing composite numbers as a product of their prime numbers. Meaning that as a product means you multiply. Product means multiplication. So we are going to express these composite numbers as a product of their prime numbers. So meaning that we must know prime numbers that are there in that composite number. Then we write the prime numbers, connecting them with the multiplication sign to give us the prime factorization. So that is theory. We have talked about the definition of composite numbers, prime numbers, and prime factorization. So already you have a clue on whatever is supposed to be done. But we are not going to be satisfied until we get all these prime factors, or we do more than one example. So prime factorization is expressing composite numbers as a product of their prime numbers. That is prime factorization. Prime factors, I mean. So let us use prime factors as a product of their prime factors, because I want us to connect with prime factors here. Prime factors are factors that are prime numbers. Then composite numbers, these are numbers with more than 2 factors. What don't you understand? Now, let us consider. Let's consider an example here. Express the following numbers. Express the following numbers as a product. As a product of. Express the following numbers as a product of. Express the following numbers as a product of their prime factors. Express the following numbers as a product of their prime factors. So you can be told, express the following numbers Or you can be told express the following composite numbers, still remains the same. If it is written numbers here, meaning that they are composite numbers, they have more than 2 factors. Now, A, what do I have as my first number? 72. B, my second number, 700. C, we have 28. Now, we have 72, we have 700, and we have 28. We are expressing these numbers as a product of their prime factors. We are expressing these numbers as a product of their prime factors. So what are we going to do? Solution. Start with A. A, what do you have? We have 72. Now, we have 2 methods of doing this. We have the table method and the factor tree method. So, we are going to do the 2 methods so that you choose your own method of doing it. Now, 72. Let me start with the factor tree. So, if we have 72, the smallest prime number, remember, we are dealing with prime factors only. The smallest prime factor that can divide 72. So, we are starting with the prime factors. 2 is my smallest prime factor that is also an even number. Can 2 divide 72? Yes. So, you start. 2. 2 divides 72 how many times? That is 36. So you continue dividing with 2 until you come up with a number that 2 cannot divide. So you exhaust the first. So we say you exhaust all the factors of 2 there. The factors, 2 as the factors there. So 2 divided 36 how many times? Correct. 18. 2 can still divide this. 2 divide 18, 9. Now, can 2 divide 9? No. Is 9 a prime factor? No. Which number can divide 9? You move to the next prime number or the next prime factor. The next prime factor that can divide 9 here is 3. Good. Now, 3. Can 3 divide 9? How many times? 3. So you see, here we have 2, 3. 3 is a prime factor, and there's no another number apart from 1 that you can divide it. So how can we write 72? We are being told that as a product. What is meant by the word as a product? As a product. As a product. What does that mean? Product means you multiply. So we say that 72 can be written as a product as 2 times 2 times 2 times 3 times 3. 2 times 2 times 2 times 3 times 3. So this now, the product is multiplication. And these are now the prime factors. I will not say that 36 is not a factor of 72. It is a factor. But we were very clear. Prime factorization. We were dealing with the prime factors. Factors that are prime numbers only. So, sometimes we say, we are tired of repeating ourselves. You cannot be repeating yourself. 1, 2, 3. 2, we are writing 3 times. There's another way of writing that. Instead of writing 2 3 times, we can write 2, then how many times? 1, 2, 3. We write that the number of times it is appearing up here. Then we multiply 3. 3 is how many times? 2 times. So we write that 2 on top here. This one is telling us that 2 is appearing 3 times and 3 is appearing 2 times. Or 2 is multiplied by itself 3 times and 3 is multiplied by itself 2 times. So this is now the same thing. This one is referred to as power form. I think we soon will look at that. But it's good, at least we amazed ourselves a little bit with a new thing. Come to the next method. I have 72. So this is now the factor tree. Let's move to the table method. Table method, I have 72. This 72, the smallest prime number that I can divide it, that is now 2. Dividing it how many times? 36 times. Next, 36 can be divided. How many times? 2 can divide that. How many times? 18. Then the same 2, how many times? 9. So 2 cannot divide 9 there. We move to the next prime number that can divide 9. Remember, we talked about divisibility test, not for nothing. It is going to help us even further. Here we have 3. 3 divide 9, how many times? 3. Then here we have 3, dividing 3, 1. So in this table method, we are listing all the prime factors in one side of the table, so that the last value remaining here is 1. Still here, the same thing, 72 is expressed as 2 times 2 times 2 times 3 times 3. This one can be written as 2 multiplied by itself how many times? 1, 2, 3. 3 times. Times 3 multiplied by itself how many times? 2 times. So this is, when we do like this one we say that we have expressed 72 as a product of its prime factors. So this is what we call prime factorization. It is not rocket science. It is just applying prime numbers, applying factors to deal with composite numbers. Part B. Somebody is asking somewhere, is it a must we start with 2? Let us have 72. 72, give me any bigger numbers that divide 72. 8 and 9. So this one can be divided as 8 and 9. So here, prime factors of 8. These ones can be divided as 2, 2, 2, divide 8, and this one 3, 3. So this one also prime factors. So no matter the number, you can start with any number, the product of two numbers that can give you that number, then you decompose those numbers. You reduce them to their prime factors. That's a way of simplifying your work. No, I told you, mathematicians, we take the challenge, then we turn it around and make it ours. And we take the shortest way possible of arriving at the same answer. Remember, what was the theme? Prime factorization. This one even can give you the prime numbers. Next, we have 700. 700. So 700, between this one and this one needs a lot of space. I can use the table method. So I'll have 700 here, use the table method. When I use the table method, what is the smallest prime number that can divide 700? Of course, it is 2. 2. 2 divide, this now where also long division is helping us. Can 2 divide 7? Yes. This now, how many times 2 divide 7? 3 times, bringing 6, remember 1. Into 10, how many times? 5 into 0, 0 times. That's 350. Good. Come to next, 2 can still divide this because the last digit is 0. 2. 2 divide 3, 1, bringing 2. Remainder, 1. Into 15, 7 times, bringing 14. Remainder, 1. Into 10, how many times? 5. Guys, it is necessary to learn the long division. Remember, it is now helping us here. I know the calculator will be doing amazing work here, but don't trust calculator all the time. Remember, the calculator can be set in a mode that you get guesses. So don't take your bag and go home because you cannot use a calculator. These are the things that you can learn as early as now to grow your brain, to think. Now, next, 3. Next prime number is 3. Can 3 divide this number? When is a number divided by 3? When the sum of the digits is divided by 3. 1 plus 7 here is 8. 8 plus 5, 13. 13 is a prime number. So this number is not divisible by 3, so we don't need to waste our time. Move to 5. Yes, the last digit is 5. 5 divide how many times? Can 5 divide 1? No. 5 divides 17 how many times? 3 times, bringing 15. Remember 2. 5 divide 25 how many times? That is 5 times. Next, 5 can still divide this. 5 divide 35 how many times? That is 7 times. Then 7 divide 7 how many times? 1 times. So you see, when you're using this method, ensure that all the last value here is 1, and factors are listed on the other side. So you can differentiate them. So you say that 700 is equals to 2 times 2 times 5 times 5 times 7. So this is what we call now prime factorization. Prime factorization. Now we say that we can go further and say we hate repetition. 2 appears how many times? 2 times. So 2 and the number of times it appears. 5 appears how many times? 2 times. 5 and the number of times it appears. Then 7 appear once. And we can just write it for formality, 1 there. So 700 is 2 appearing twice times 5 appearing twice times 7 appearing once. Now, I can apply also this method since it is hard for me if it is hard for me, I want to simplify 700. It is hard to use it like this. I can say 700. 700, 2 numbers that if I multiply, I get 700, that is now 70 and 10. I can decompose. This one gives me how many prime factors? This one gives me 2 and this one is giving me 5. Then this one I can also decompose this one further and say this is giving me 2 and this is giving me 35. This is a prime number, this is a prime number, this is a prime number. But this is not a prime number. I can decompose it further and say this one is giving me which 2 numbers if I multiply give me 35. That is 5 and 7. So you see, this one is another way. Just take big composite numbers. A bigger composite numbers can be divided into smaller composite numbers. These smaller composite numbers can be divided into smaller composite numbers and prime numbers, and we can continue dividing that composite numbers until we come with all prime numbers. So here we say that it is 700 is equals to 2 times 2, this 2 times 2. So we always start with the smaller prime factors first. Then we move to the next in ascending order. 2 times 2 times 5 times 5 times 7. This still giving us the same thing. 2 twice, 5 twice, and 7 once. Now, C, we have 28. Guys, can you just do this? Express for me 28 as a product of its prime factors.